term ton in the context of alternating current compressors refers to the cooling capacity of the unit, roughly equivalent to the amount of heat it can remove from a space in 1 hour. The conversion formula is 1 ton equals 12,000 British thermal units per hour. As an example, an alternating current compressor rated at 3 tons has a cooling capacity of 3 tons times 12,000 British thermal units per hour per ton, which equals 36,000 British thermal units per hour. There is a commonly used rule of thumb to estimate the appropriate tonnage for a given space. This is square footage divided by 600 equals ton rating. For a space of 2,400 square feet, 2,400 square feet divided by 600 equals 4 tons. The rule of thumb is a rough estimate, and factors such as insulation, ceiling height, and sun exposure can affect the actual cooling requirements. Alternating current compressors are typically oversized by 10 to 15% to ensure sufficient cooling during peak periods. Larger compressors are not necessarily better. The oversizing can lead to short cycling, inefficient operation, and increased energy consumption. It is always advisable to consult with an heating, ventilation, and air conditioning professional to determine the appropriate tonnage for the specific space and needs. In more detail, let's explore the relationship between tons and British thermal units per hour. A ton of cooling is defined as the amount of heat required to melt 1 ton, that is 2,000 pounds of ice at 32 degrees Fahrenheit in 24 hours. This translates to 12,000 British thermal units per hour. British thermal unit is a unit of energy. It represents the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. So, a 1 ton alternating current unit can remove 12,000 British thermal units of heat from a room in 1 hour. To calculate the required tonnage, you need to estimate the heat load of the space. This involves considering several factors. Firstly, square footage is considered. The larger the space, the more cooling is required. Secondly, insulation is considered. Hood insulation reduces heat transfer from outside, lowering the cooling load. Thirdly, ceiling height is considered. Higher ceilings increase the volume of space to be cooled. Fourthly, sun exposure is considered. Rooms with more sun exposure require more cooling. Fifthly, number of occupants is considered. Each person generates heat, increasing the cooling load. Sixthly, appliances and equipment are considered. Heat-generating appliances contribute to the cooling load. The rule of thumb, square footage divided by 600, provides a quick estimate. However, it is crucial to adjust this estimate based on the other factors mentioned. For example, a poorly insulated room with high sun exposure may require a larger tonnage than estimated by the rule of thumb. Alternating current compressors are often oversized to ensure adequate cooling on the hottest days. However, oversizing can lead to problems such as short cycling. Short cycling occurs when the compressor turns on and off frequently. This is inefficient and can reduce the lifespan of the equipment. An oversized compressor cools the space too quickly and then shuts off. As the temperature rises slightly, it turns back on. This frequent cycling wastes energy and can damage the compressor. An appropriately sized compressor runs for longer periods and maintains a more consistent temperature. This is more efficient and extends the life of the compressor. Consulting with an heating, ventilation, and air conditioning professional is essential for determining the correct tonnage. They can perform a detailed heat load calculation and recommend the appropriate size compressor for the specific application. A professional will consider all the relevant factors, including insulation, sun exposure, and the number of occupants. They can also advise on the most efficient type of compressor for the application. Variable speed compressors, for example, can adjust their cooling output to match the actual cooling load. This can save energy and improve comfort. Proper sizing of an alternating current compressor is crucial for efficiency and comfort. The ton rating is a measure of cooling capacity. While rules of thumb can provide a starting point, a professional assessment is always recommended to ensure optimal performance. Consider the long-term benefits of proper sizing and professional consultation, which includes reduced energy bills, increased equipment lifespan, and improved comfort. Ignoring these factors can lead to increased costs and decreased performance. The benefits extend beyond monetary savings. A properly sized system contributes to a more comfortable and healthier indoor environment. It minimizes temperature fluctuations and reduces humidity levels, creating a more pleasant living or working space. It is also important to consider the environmental impact. An efficient alternating current system consumes less energy, reducing carbon emissions and contributing to a more sustainable future. In conclusion, understanding the TAN rating of alternating current compressors and how it relates to cooling capacity is essential for making informed decisions about heating, ventilation, and air conditioning systems. While simple rules of thumb can be helpful, a thorough assessment by a qualified professional is crucial for ensuring optimal performance, efficiency, and comfort. Remember to consider all relevant factors, including square footage, insulation, sun exposure, and the number of occupants. Also, avoid the temptation to oversize the compressor, as this can lead to short cycling and other problems. By taking a holistic approach and seeking expert advice, it is possible to achieve a comfortable, efficient, and sustainable indoor environment. The formula 1 ton equals 12,000 British thermal units per hour gives you the direct relationship for how much heat the air conditioner can remove. The rule of thumb of dividing square footage by 600 is a rough estimate. This estimation method does not account for other factors like the regional climate, window sizes, or insulation qualities. When dividing square footage by 600, you are essentially assuming a moderate climate with standard insulation. Therefore, it is an excellent starting point, but remember it has its limitations. It is important to note that heating, ventilation, and air conditioning professionals use software tools and industry standards to perform load calculations for the specific building and its location. These calculations are very detail-oriented to ensure proper sizing of the alternating current compressor. Oversized systems are also more expensive to purchase than needed. They also consume more energy due to frequent short cycling and inefficient operation. Conversely, an undersized system will run continuously but will not be able to maintain the desired temperature, especially during peak times. As a result, it will consume more energy trying to keep up. The goal is to select a unit that closely matches the calculated load, keeping it energy efficient, comfortable, and providing long-term cost savings. When consulting with an heating, ventilation, and air conditioning professional, make sure to ask about the seasonal energy efficiency ratio, or SEER rating, and the energy efficiency ratio, or ER rating, of the alternating current system. These ratings provide information on the energy efficiency of the unit, allowing you to make a more informed decision. Higher ratings generally indicate greater energy efficiency and lower operating costs. Beyond the technical specifications and calculations, consider the reputation and experience of the heating, ventilation, and air conditioning contractor. Look for a licensed and insured professional with a proven track record of providing quality workmanship and excellent customer service. Check online reviews and ask for references to ensure you are working with a reliable and trustworthy contractor. Also, clarify warranty terms and maintenance requirements to protect your investment and ensure the long-term performance of your system. It is also important to consider the long-term costs associated with maintaining the alternating current system. Regular maintenance, such as cleaning or replacing air filters, is essential for maintaining optimal performance and preventing costly repairs. Consider a maintenance plan with a qualified heating, ventilation, and air conditioning contractor to ensure your system receives regular checkups and preventative maintenance. Another aspect to consider is the noise level of the alternating current system. Noisy units can be disruptive, especially in residential settings. Look for units with low noise ratings, typically measured in decibels. Consider the location of the outdoor unit and ensure it is placed in a location where the noise will not be a nuisance to you or your neighbors. Consider also the type of refrigerant used in the system. Older refrigerants, such as R-22, are being phased out due to their environmental impact. Newer refrigerants, such as R-410A, are more environmentally friendly. Look for systems that use environmentally friendly refrigerants to minimize your carbon footprint. Take the time to gather all the necessary information, consult with qualified professionals, and weigh all the factors before making a decision about your alternating current system. By doing so, you can ensure a comfortable, efficient, and sustainable indoor environment for years to come. Also keep in mind the impact that humidity has on comfort and efficiency. In humid climates, the alternating current system has to remove both heat and moisture from the air. This can increase the load in the system and reduce its efficiency. Dehumidification systems can help reduce humidity levels, improving comfort and reducing the load on the alternating current system. Be sure to address humidity levels with your heating, ventilation, and air conditioning contractor to ensure optimal comfort and efficiency. As technology advances, smart thermostats, smart sensors, and zoning systems can be integrated with alternating current systems to further enhance comfort and efficiency. Smart thermostats can learn your preferences and automatically adjust the temperature to optimize comfort and energy savings. Smart sensors can detect occupancy and adjust the temperature accordingly. Zoning systems allow you to control the temperature in different areas of your home or building, providing customized comfort and energy savings. Stay informed about the latest advancements in alternating current technology and consider incorporating these features into your system to maximize comfort, efficiency, and sustainability. In conclusion, selecting the right alternating current system involves a comprehensive assessment of your cooling needs, consideration of various factors, and consultation with qualified professionals. Understanding the ton rating, British thermal units per hour, and the various factors that influence cooling load is essential for making informed decisions. By taking a holistic approach and staying informed about the latest advancements in technology, you can ensure a comfortable, efficient, and sustainable indoor environment for years to come. Be sure that you always follow building codes and permitting requirements when installing or replacing an alternating current system. These codes and requirements are in place to ensure the safety and efficiency of the system and to protect the environment. Obtain the necessary permits and inspections to avoid costly fines and ensure compliance with local regulations. It is also important to consider the long-term impact of your decision on the environment. Choose energy-efficient systems that use environmentally friendly refrigerants to minimize your carbon footprint. Proper maintenance and disposal of old units are also essential for protecting the environment.